When we think of math, we think of patterns. And one of the most basic patterns is arithmetic sequences. We're going to be looking at those in series. So when I'm talking patterns, I'm talking like I could look at it and see, okay, what's going to be the next number. So for instance, if I have 3, 8, 13, 18, ... I could look at this and say, okay, well, the next one is going to be 23. And then the next one is going to be 28. Because each time we are adding 5. Okay, so this isn't a pattern. Now, there are two different ways that you could look at this. The way I'm doing it currently is I need the first term in order to figure out where I'm going. Okay, so this is using a previous term. This is what we call a recursive formula. So our A1 is going to equal a number, AN, which the AN, all the A represents is that it's arithmetic. That way you know. The N just represents the number of terms. So this is going to be AN minus 1, aka the previous term, plus your D. Okay, so let's a little note over here. N equals number of terms. D is your common difference. Okay, so you are adding and subtracting a number. By the way, I forgot to mention this. An arithmetic sequence is when you are adding or subtracting by the same number. My bad. So the nice thing with the recursive formula is it's a pattern. You can just set it up on your calculator or in your head to think, okay, I'm adding the same number each time. The problem is you have to have the previous term in order to figure that out. There is another way in order to figure out, say for instance on the pattern I'm working with there, that I would like to have I want to know the 100th term. I'm not going to go through and add all those numbers until I get to the 100th term. I'm going to want, a formula. This is what we call explicit. The explicit formula is AN equals A1 plus N minus 1 times D. Again, all of those things from prior, such as the N and the D, are all the same. A1 just represents the first term. Actually, let's go back and put that in there. Okay. So for instance, let's say that my first term, A1, is 6 and D is 4. Okay. If I'm going to ask, I would have two separate questions maybe. What is A3? Question mark. Let's deal with that one. This one's probably going to be easier just to use the recursive formula versus the explicit formula because A1 is 6. I'm adding 4, so that's 10. And the third term is going to be 14. So that one, it might be easier just to use the recursive formula. You just add, right? Now, let's say I want the 20th term. That one's a little bit more challenging, so I then need to go through and use my explicit formula, and that's okay. So A20 equals 6 plus, well, what is N? N is the term number, right? So that would be 20 minus 1 times 4. I always like to put that my common difference in parentheses. The reason being is because if you have a negative number, I don't want you to think that it's -6 or whatever that may be, just because it kind of looks like it versus multiplication. So that does make a difference. So you can just plug this right into your calculator or Desmos or whatever it is, or do it in your head, I don't care. And we would see that A20 is 82. Now, so those are all sequences. Those are finding terms within our information. Now, a series, however, is the summation of all of those terms. And they will give you like an upper bound and a lower bound on that. So there is a formula for this. And it is n times a1 plus an divided by 2. Now, the tricky part with this one is you need to know that your n's are the same, and sometimes they're not, and that's something that you have to work around in order to figure out. So for instance, let's say that I have six plus 13 plus 20 plus 27 plus ... plus 97. Okay, so looking at this information, I have A1 as 6, N, I don't know, AN is 97, and D, if I'm going from 6 to 13, that's a plus 7 each time. Well, shoot. In order to use my series formula, I need to know the n. So I'm going to have to use the explicit formula in order to even get to find my n to use my summation formula. That's not a big deal, okay? You just have to intermix between the two. Okay, so an is 97, a1 is 6, n we don't know, but we can find, and d is 7. I now have to use just a little bit of algebra in order to figure out that n. So I'm going to subtract the 6. 91 equals n minus 1 times 7. I'm now going to divide that by 7 to get 13. Add the 1 over. N equals 14. I now have all of my information to use the series formula. So we have S of 14 technically equals 14 times 6 plus 97 divided by 2. I'm going to go ahead and just type this in. And my answer is 721. So sometimes you have to use the explicit formula in order to figure out the series formula, or vice versa. You're just going to have to intermix between those, and you're just looking for the pattern and how to get to the end result of your pattern. There is one other thing I need to touch base with quick, and that is sigma notation. Which is just representing a series. Sigma is this sign. It's a Greek letter. We use a lot of Greek notation in mathematics. It's really not a big deal. It's just something for you to know, because you might see it, and I just want you to be aware of what it is. So what this represents is I represents the initial. We always start with a series formula, generally with the first term. So I is the first term. A is kind of whatever formula they give you. N represents still number of terms. So it's just a little bit different of a notation. All it just represents is that you need to add those together. So for instance, we'll do a quick example here. So if I'm looking at this, what I always do is I just substitute those numbers in. So I would have 2 times 1 minus 4, which equals negative 2. 2 times 2 minus 4. So what I'm doing here is I have to start at 1, so that's what I'm entering. My last term will be the 4. Which is here. And then I just add these together. And voila, there's my sigma notation. It's just a different way to look at it if you don't have a formula.